So today we'll talk about our second chapter, which is on fractions. I think many of you already have seen fractions. So in fraction we have two different number, right? One is called denominator, which is basically at the bottom, and one is numerator, right? Because any fraction should look like this, right? So the number at the bottom is the denominator, right? And number at the top is a numerator, and both of the numbers itself are like whole numbers. So, but the idea of the fractions come from such things like, for an example, if you think this is a whole circle, that's a whole number basically. So one circle, right? So that means this is a one single part. But for an example here, this circle is divided into two equal halves, right? So that means one half is basically the half of the circle, right? So that's how is, you see this is a fraction. Here again, we just divided the circle into four equal parts. So each part is a quarter, which is again 1/4 is a fraction. So we tried to show you that how we can divide something into equal parts, because if you look at all these images, you see all the parts are pretty equal. How we divided, they're equal, okay? So pretty much what we did is we had at the beginning we had one single thing, and we divided into 4 or 8 or 16, right? And then each of the part become 1/16 or 1/4 since we divided into 4 or 16 or 32 or 8 or whatever, okay? Look at the last one. There was a one square, right? And we divided that into 16 equal pieces. That means each of the pieces becomes 1/16. So simply that means we had something 1, and I divided that by 16. Remember, this only happens when you divide something into equal parts, because if they are not equal, then it will be something else, okay? It will be still fraction though, but not exactly how we see right now here, but that was the simplest one. Now let's say we have a fraction 3/4. What is numerator here? Numerator is of course the one we have at the top, right, which is 3 in this case. What is denominator here? 4, right? The number we have at the bottom. Now let's see whether we understand a word problem using fraction. Let's say before serving our pizza at the party, I divided up the pizza into 12 equal pieces. It's just like the previous one. Remember, we divided the circle into 12. It's pretty similar to that. Then I ate 3 slices of pizza. How much of the pizza did I eat? So, okay, first of all, the pizza, we had 12 equal sizes. Look at the equal, the word equal, because it's equal size, that's important. So, and I ate how much? 3/. So this is what I ate, right? Because out of 12, I ate 3. So technically that is 3/12, but if you can simplify it down like this, you can just write at the top 3 times 1, at the bottom 3 times 4, since you want to simplify a little bit to make it simplest fraction. I'm sorry, 1/4. So the right answer is B. So that means I ate 1/4 of the pizza, 1/4. Okay. Let's see whether we understand this problem. I bought a bag of apples that contained 20 apples, and I used 15 apples for a cobbler. What fraction of the bag did I use for? Pretty similar problem. What might be the right answer? So the right answer is B, right? So 15/20, which is, again, if you simplify, you get 3/4, right? So since we are using 15 out of 20, right? Again, those are equal. We are assuming that all the apples are equal. May not be equal because it's hard to make it equal, but pretty close. Then if we simplify it, 3 times 5, 4 times 5, then we get 3 over 4. That's how it may be 3 over 4 or 15 over 20 is the same, right? Now, number with fractions or without fraction. Number without fraction means we have all whole numbers, right? Like 1, 2, 20, 50, 60, all these are whole numbers. Remember, whole numbers can be negative as well. Okay? But some numbers contain whole number and a fraction both. Those numbers are called mixed number, like these ones you have at the bottom. So you see here 4 half. So 4 is a whole number, but half is a fraction. So when you have such numbers like this, like 8, 2 over 3, then 6, 10 over 4. So you see here, 8 is a whole number, 2 over 3 is a fraction, 6 is a whole number, 10 over 4 is a fraction. These sort of numbers are called mixed numbers. And also in fractions, there are two kinds. One fractions are called proper fraction, where we have numerators always smaller than denominator, like these ones. You see here all the numerators, meaning the number you have at the top or at the beginning, is smaller than the later one or bottom one. Okay? So those are proper fraction. But if that is not the case, like here, meaning the numerator is larger, greater, right? For an example, here numerator is 5, right? And the denominator is 2, but the numerator is higher, right? It's more than denominator. Those numbers are called improper fraction. Okay? Any question here? Okay, let's first see whether we can identify the numbers. Now we know we have whole numbers. You know, we always knew that. But we have mixed numbers, we have proper fraction, we have improper fraction. Let's see whether we can identify those first. Now what is this? 1 half. That's a mixed number, right? Because there is a whole number which is 1 and there is a fraction which is half, right? This is a whole number, of course. What kind of fraction? This is a fraction, right? This is a proper fraction because the first number or the top number, meaning which is numerator, is 2, which is smaller than the denominator, which is 3, right? How about this one? Improper, because the numerator is larger. Numerator is 7, right? And the denominator is 5. Okay. Now, just like the whole numbers, we can measure the fraction using scales. Now, or ruler, whatever. So different fraction can represent the same length sometime. For an example, if you look at this scale, if you have 6 division, for an example, this is 1 division, this is 2 division, second one, 3, 4, 5, 6. So up to here you have 6 division starting from the left side, right? Now, this 6 division can be represented in several different ways. Now, if you look at carefully, you see up to here this is 1, right? And then this is basically the middle of 1 and 2. That means you are at 1 half. So instead of just writing 6 division, you can write 1 half. You can also write 3 over 2, because what this means is, if you consider from here to here, this is 3, right? But this is the midpoint between 0 to 3. So that means this is half of 3. But, you know, technically all these are the same thing, okay? No matter how you write, all these are the same thing. So that means any fraction can be written in different forms. But most of the cases we probably prefer the simplest form. We'll talk about that soon. So can we read that how much is this? So for an example, up to here this is 2, right? And then we have 4 divisions between 2 and 3, and we just passed 3 division out of 4. So the reading is C, right? We have 2 as a whole number, and then from the next part we passed 3 divisions out of 4. Any question here? 2, 3 over 4. How about this one? If we again, as I said, we can just represent the same thing in different manners, right? Now, still we are in the same place, but you see there is no 2, 3 over 4. So we might be able to try it in a different way, because we can see from 0 to 3, if you think about the smallest division, how many divisions you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means you pass 12 out of 11. I'm saying 11 out of 12. So that means that one way. But you can also think like 11 over 4. That's another way, because what you can do is this. Sometimes you can write the, let's say this is a mixed number, right? This is a mixed number because there is a whole number, there is a fraction. So you can write this as an improper fraction. How you can do that? All you need to do is you have to multiply these two and add this. That means from here, you have to multiply the whole number times the denominator and then add the numerator, which makes 11. 4 times 2 is 8 plus 3, and then this is going to be 11 over 4, meaning this number will be exactly the same, and 11 will be coming from here. Okay, we'll show you how to do this again. Okay, this is like you can convert any mixed number to fraction. So we'll do it soon here. So this is the same thing. We just first have the steps. That's still the same thing. So how to change a mixed number to an improper fraction? Because any mixed number, no matter how it looks, we can change it to improper fraction. So in the mixed number we have one whole number, right, and one again fraction where we have a numerator and denominator. What we do is we multiply excuse me we multiply the whole number and the denominator. So the whole number is 4, right, and the denominator is 5. We multiply them, we get 20, and we add the numerator. That makes it 23. And then we write it, and the 23 is going to be our new numerator, because the denominator still remains same. In the original number, your denominator was 5, right? So that denominator is still 5, but the 23 is coming from here, because we multiply 4 times 5 plus 3. Okay. Similarly, we can change the improper fraction to a mixed number. This is the reverse way. So if you have improper fraction, meaning where your numerator is greater than denominator, like here, so the numerator is 27, right? And then denominator is 5. What you need to do is, for an example, you need to divide it just like a third grader. For an example, let's say you divide 27 by 5, just like a third grader. Don't do it in the calculator, because the calculator will give you a fraction, right? You will not have the remainder. So I just write 5 times 5 is 25, and then we have a remainder 2, right? So this is the remainder. 2 is the remainder, and this is called the quotient, right? So after you are done with this, the quotient comes as a whole number, and then remainder comes as a numerator. Denominator still remains same. In the original number, denominator is 5, right? Which was this. So denominator still remains same. So you divide it. After you divide, the quotient becomes your new whole number, and the remainder becomes your numerator. denominator still remains same, because in the original number you had what, 27 over 5, right? You see this 5 is still same. Let's see whether we can do a little bit of these conversions. So we have an improper fraction here, right? Can we convert it to mixed number? What would be the mixed number? Is this C? Because we divided just like how we did here. This is 5 times 5, 25. So the 5 is going to be your whole number, and the remainder is 1, right? That's going to be your numerator, and the denominator is still stays same, right? How about here, 17 over 4? So the right answer is D. This is a mixed number, right? Can we convert it to improper fraction? We multiply what? Whole number times denominator, right? Plus numerator. So 3 times 8 is what? 24. Plus numerator, which is 5. So 24. So what we do is this. So 3, we multiply these two, right? 3 times 8, and then we add these. 24 plus 5, 29. So this is going to be our new numerator, but the denominator still remains same, right? Denominator still remains same. So 29 over 8, which is the right answer, C, right? So the right answer is 17 over 3, right? A. Now, remember, so far we know that we can write the same fraction in different form, right? So it might be confusing in some cases that. So that's why what we do is we find an equivalent fraction we can find an equivalent fraction. For an example, I give you two different fractions, and I asked whether they are same or not, because they may not look like same, but they are same, right? So how do I know it? What we can do is we can always find an equivalent fraction which is the simplest fraction, meaning you cannot go beyond this, meaning that's the simplest. Then all the fractions, if they're equal, let's say I give you two fractions, and if they're equal, you will know exactly whether they're equal or not, because you can convert every fraction to simplest fraction. Okay? How you can do that? To do this, what we do is we can just convert any fraction to simplest form, but also to check whether the fractions are same or not, what we can do is we can multiply or divide the numerator and denominator by the same thing. If you do that, it will be different, it will be changed, and it will be different, but it will be still the same fraction. For an example, if you look at the first example, the original fraction is 1 over 3, but we are multiplying both by 4. After the multiplication, the fraction becomes 4 over 12, but 4 over 12 and 1 over 3 is still the same thing. And the second example, we have 12 over 15. We divided both. So as long as you do the same operation to both numerator and denominator, whatever you get will be still the same fraction. It will not look like the same. I'm saying numerator denominator is changing, but it's still the same. It's equivalent. Okay. So, but still, as I said, we have multiple forms of same fraction. So to see whether two fractions are equal or not, we always want to find the lowest terms of meaning the simplest terms of a fraction. To do that, first we need to know can I find, how can I find the factors of a number? Okay, meaning most of the numbers have some factors. For an example, you can write 6 as 1 times 2 times 3. Now all these numbers like 1, 2 and 3, these are factors of 6, because if you multiply the factors you get 6. But none of these numbers like 1, 2 and 3, you cannot divide those numbers as a product of other 2. For an example, you can write 4 as 2 times 2, right? But can you write 2 as something else? I'm saying you can just write 1 times 2, but that doesn't make that much difference. Except that you cannot write. So any number which is like, you cannot divide the number as a product of other 2 number, that is a prime number. Those numbers. So we have several prime numbers, plenty of prime numbers. Like 3 is a prime number, 2 is a prime number because you cannot divide those numbers. But 4 is not a prime because you can write 4 as 2 times 2. 5 is a prime number, right? 6 is 6 a prime number? No, because why? Because you can write 6 as 3 times 2, right? How about 7? Of course 7 is a prime number. How about 8? Because you can write 8 as 2 times 2 times 2, which is 8. 9? Not a prime as well, right? Because you can write 9 as 3 times 3. 10? 5 times 2. It's not a prime. So 11? 11 is a prime. So, you know, as you can see, there are several prime numbers. So, pretty much whatever the number is, if we just convert the number into multiplication or product of different prime numbers like we have here. For an example, let's say 6, we just wrote 1 times 2 times 3. So here, 2 and 3, those are primes. 1 is also a prime, but you know, that's a very generic version because that's like everywhere there is 1 multiplied. So 12, you can write 4 times 3, but this is not done yet because you can divide 4 again into 2 times 2. So pretty much 2 times 2 times 3 will be the prime for 12. Okay. So to get the lowest terms, we need to know how do we divide, how do we like write the number as a product of several prime numbers. Like here, let's say we have some more examples. Let's say 55. You can write as 5 times 11 because 5 and 11 both are primes, right? You cannot go beyond. I'm saying you cannot divide 11 anything, you know, further, or 5 anything else, right? Similarly, 15. 1 doesn't matter whether you keep 1 or not, but 3 times 5 is there. Now, again, what we are looking for is we are trying to find a lowest terms of a fraction. So where whatever the numerator or denominator you will have for a fraction, that will be the lowest denominator and numerator because you cannot have lesser than that. Okay? So let's see whether we can understand the prime first. Now tell me what is the prime of 36 in the list, from the list. Which ones are the primes? Is this a prime here? Because you see the 12 is not a prime, right? Because you can divide the 12 as 3 times 4, then you can also divide the 4, so it's not a prime anymore. This is not a prime either, right? Because 6 is not a prime. How about here? So the last one is the prime of 36, right? Because pretty much 2, 2, 3, 3, all of these are primes. Okay? 42. Which one? First one, right? Because 7, 3 and 2, all these are primes. So the right answer is A. Okay, let's see how we can use this prime to reduce any number into lowest term. So you can read the steps, but most of the cases we just go by the example because, you know, if you understand the example, you'll understand the steps. So for an example, you are given a fraction here, which is 16 over 24. To get the lowest term, what we do is we write the numerator and denominator as a product of prime. So what we did is we just wrote 16 equals to 2 times 2 times 2 times 2 because those are the primes of 16, right? 4, 2. If you multiply 2 times 2 times 2 times 2, you get 16. Similarly, we just wrote 24 as a factor, prime. Okay? So then once you have it, you try to cancel whatever is possible. You can cancel between numerator and denominator, because here you have 3 2 and 3 2 common, right, at the top and bottom, so you can cancel out all those 2's. So, and you'll be left with only 1 2 and 1 3 at the top and bottom. So something like this. You have, so you have 4 2's, right, at the top, and at the bottom you have 3 2's and 1 3. So you can cancel same number at the top and bottom, and you'll be left with only 1 2 at the top and 1 3 at the bottom. So that means 2 over 3 is an equivalent fraction of 16 over 24, but at the same time 2 over 3 is the lowest term for this fraction, because he cannot find anything else lesser than 2 at the top or lesser than 3 at the bottom for this fraction. These are same fraction, but you can just write the same fraction as the lowest term. Let's see whether we can find this reduced term for this one. You can try in page and paper in case you want to see how you divide it into factor. So 12 over 36, 1 over 3, C. How about this one, 15 over 25? How do you divide the fraction? 15 over 25. 15 over 25. 15 is what? 5 times 3? 25, you can write 5 times 5. And then you can cancel 5 and 5 at the top and bottom. So you'll be left with 3 over 5, right? Which is B. Because once you just divide the number into prime factors, it's simple. Now let's see how we add fractions. So for an example, we are trying to add these two fractions here. When you add fractions, what you need to do is you have to have the same numerator. Now are the numerator same here? No, right? Because one numerator is 4 and other one is 8. Now how do I make it same? To make it same, you can multiply this by 2, right? But remember, if you multiply this by 2, you have to multiply this by 2 as well. Because you have to multiply. Remember I said, if you multiply or divide by the same number, meaning the numerator and denominator both, then it's still same. So what we are doing is we are multiplying. We just want to make it 8, this one. To make it 8, we know that we have to multiply it by 2. But you cannot just multiply this one, you have to multiply both. So we multiplied both and this becomes 6 over 8. Now we have same numerators. Same denominators. Now once you have same denominators, we are ready for addition. What do you do in the addition? We keep the denominator same, but we just add the numerators, right? So we add them. 6 plus 3 makes it 9. Now since this is 9 over 8, this becomes an improper fraction. See, in the pause when you do this problem, you have to look at how the answer is given. Answer might be given as improper fraction. Then you are done here. But if the answer is not given as improper fraction, answer might be given as mixed number. Then you have to do one more step, convert it to improper fraction. Okay? You know how to do the improper fraction, right? Just divide 8 by 9 and then keep the remainder as your new numerator, right? It depends. You'll see the answer if it is in different form. So to do the subtraction, we still need the same thing. We still have to have the numerator same. Denominator same. To do the denominator same, again here, we need to make it 8. Because we need both to be same. To make it 8, we multiply both by 2. Now we are ready for the subtraction. So we keep the denominator same, but we subtract the top ones from the first one, from the second one from the first one, right? So 6 minus 3, which is 3, 3 over 8, we are done. So let's see whether we can add. So 2 over 4, 1 over 2 plus 1 over 4, right? So again, we first have to make the numerator same, denominator same, right? Half plus 1 over 4. How do I do it? I just multiply both by 2 in the first number, since I want to make it 4. Then it is 2 over 4 plus 1 over 4. Then I add only the numerators. I keep the denominator same. So right answer is 3 over 4, right? So the right answer is C. How about this one? Can you try to add and see? Right answer is B, right? So B is given as both, as a mixed improper fraction and mixed number. How about this one? This is ready for subtraction because your denominator is same, right? But after the subtraction, how much you get? 5 over 5. But that exactly means 1. Because when your numerator and denominator are same, you can cancel out and you just write 1. Because that's a whole number. So the right answer is A. Seven over 15 minus 2 over 5. Again, your numerator has to be same, right? 7 over 15 minus 2 over 5. So you multiply both by 3 to make it 15 each, right? So it's 7 over 15 minus 6 over 15. Now you are ready. So it's 1 over 15, right? So the right answer is the last one, right? D. How do we multiply the fraction? Multiplication is easy because you don't have to make the denominator same. Okay? As long as both are in improper or proper fraction, because you see at the beginning we have mixed number, we convert it to, because we cannot multiply the mixed number, we have to we have to convert it to either, I'm saying we need either improper or proper fraction. So we convert the mixed number into improper fraction. Once you have it, it's easy because you multiply the top and bottom. So if you multiply here, both of the numerators, 3 times 11 is 33, 8 times 4 is 32, you are done. But sometimes if you need a mixed number, again you convert it back to mixed number because this is an improper fraction. Since this is larger, right, than denominator. How do you divide? Division is also easy. So you just convert all the mixed number into improper fraction. But for the division, what we do is, let's say we have to do this division. We change the division into multiplication, and we flip the last number. You see, we flipped it here. Look at this. We flipped it, right? Like it was 11 over 8, we just wrote 8 over 11. And we changed the division into multiplication. Because all the divisions is just like a multiplication. Once you flip the second number, do not flip the first number because the first number will be still same. So once you flip the second number, the rest is same because you just do the multiplication, right? So 3 times 8, 24, 4 times 11, 44. But after you are done with these, you might be able to get a lowest term, which we had here, right? Because it's 24 over 44, and we tried to make it simple, lowest term, using the prime factor. Using the prime factor like this. For an example, it was 24 is over 44, so it's 4, 2 times 11 at the bottom. And at the top is like 2 times 2, 3 times, okay. So these are the factors, right? Prime factors. So I cancelled 6 over 11. But division is nothing but just a multiplication. Okay, you change the division into multiplication and flip the second number. Let's look at a couple of examples, and then we'll go to the quiz section and we'll do the two quizzes. You will see chapter 2, quiz 1 and quiz 2. Okay, it's pretty much the similar problems we have there. So again, this is a multiplication, so we just multiply the numerators and denominators, right? Numerators you multiply 5 times 3, that becomes 15, and 6 times 7, 42. So 15 over 42. Right answer is A. Sometime you might get a chance to simplify, right? I think this is an example where you have a chance of simplification. What will be the answer here? 2 over 9 times 6 over 8, right? So 2 over 9 times 6 over 8, 12 over 72, but you can of course simplify it down. So you can write 2 times 3 for 12, right? For 72 you can write 2 times 3 times 3 times 2. All the factors. See, sometimes it's easy to get the factor if you do this. Let's say you want to find the factor of 72. Start dividing it by, let's say, 2. If it is possible. Sometimes it may not be possible by dividing by 2. Sometimes you see it might be 3 or 5. So start dividing it by any factor. I'm saying prime factor, prime number. So let's say I divide by 2, I get 36. I keep dividing as long as I can. Again I divide it, 36, I get 18. I again divide it by 18, I get 9. Now I'll have to divide by 3, I get 3. I'm done. Because I cannot divide any further. So all these are now factors. 2, 2, 2, 3, 3. Some people find it useful. And then you write all of these as a factor. Then you cancel out. So you have 1 here. Because you can assume anytime there is a 1. So you'll be left with 1 over 6, right? So the right answer is C. Sure.
Can you not just do 12 more than 12 more times 12 divided?
Of course I can do that, but I tried to show you the ideal way of doing it. Yeah, we can always do that. You see, somebody was, she's asking, can we do just 12 times 6? But I always wanted to show you the ideal way of doing it. We always know this 1 over 6, but sometimes it may not be too easy if it is like a larger number. You always want to go by the original way of doing it. Okay. Division. Division is nothing but a multiplication, right? Just flip the second number. How much you get? 2 over 9 multiplication 6 by 2, right? So this is going to be what? 2 over 9 multiplication. I flip the second number. So you can even cancel before you start. So it's 6 over 9. You can still simplify it down because it's 2 over 3. So it's like 2 over 3, right? The right answer is A. Any question here? Okay. Remember, you always want to probably reduce to the lowest term, okay? Whatever the outcome is of multiplication and division. 7 over 8 divided by 14 over 24. What is the right answer? Seven over 8 multiplication, I flip the second number, okay? 24 over 14. So what you can do is sometimes even if you multiply, before you multiply, you can simplify it down and cancel out, because it's sometimes easy, because if you multiply it becomes a big number, And to get the prime factors are hard. Okay. So what you can do is this. 7 is already a prime. But 8 you can just write 2 times 8. And then 24 you can write prime factor 3 times 2 times 2 times 2. And then 14, 7 times 2. Now the reason I did that, because before I multiply, I prefer to get all the factors. Because it's easy. Because after you multiply, that will be like, let's say 740. Now, to get the prime factor of 740 is like, you have to again think and then do those divisions. But it's sometimes easy if you before multiply, if you get the factors and then cancel out and then you multiply at last. Sometimes it's better. So, I cancel all of these 2's, 7. I'm reduced to it only 3/2. And then if I just convert it to mixed number, it's 1/1/2, right? 1/2. So the right answer is D. Okay, I'm saying, you can probably multiply 8 times 14 and then you factor it out, which is like, again, a lot of factoring you need to do. So this is the final chart. Addition, subtraction, multiplication, division in one table. See how we get those. I'm saying all the, summarizing all the steps. How you do it, okay? So let's go to the quiz section. There are 2 quizzes for this chapter. So pretty much for all chapters we have quizzes. And I'm going to open all the next quizzes as well, so that in case you want, you can move ahead and you can just try the next ones. You don't have to wait until we are doing here, but in case you can try. Okay, and then pause records always the highest grade in quizzes. So if you try again and again and you get 100%, that's the best. Okay, any question? Okay, let me stop the presentation and let's go to pause, go to the quiz section and let's try the 2 quizzes for this chapter 2. Okay.